Problem 3 wants us to use the definition of the derivative to differentiate 4x minus 1 over 3 minus x. So just like before, I'm going to simplify my difference quotient and then take the limit of the result. So f of x plus h is going to be 4 times x plus h minus 1 divided by 3 minus x plus h. So notice that I'm always putting x plus h in parentheses when I plug it into that first step, because I need to make sure that I'm distributing things properly, I'm distributing my 4 across properly, and then I'm going to distribute this negative sign across properly. So now I'm just going to simplify this expression, and in the numerator I get 4x plus 4h minus 1, and in the denominator I get 3 minus x minus h. So now if I set up my difference quotient, since I can see here, right, that f of x plus h is going to be a rational expression, and f of x is going to be a rational expression. Basically what I'm going to end up with is 2 fractions in the numerator then divided by this h. So what we can do, just to make things a little bit easier on ourselves, is, well, we can assume that this h is over 1. So if I divide a fraction by a fraction, I can multiply times the reciprocal. So just to make things work a little smoother, I can actually say, well, this is the same thing as 1 over h times my numerator. So I'm going to put f of x plus h in first, so that was 4x plus 4h minus 1 over 3 minus x minus h, and then I'm going to subtract 4x minus 1 over 3 minus x. So I need to get a common denominator here. So to get the common denominator, I need to multiply this expression by 3 minus x, and I need to multiply this expression by 3 minus x minus h. So I'm going to start here. So we're going to have 4x minus, or plus, excuse me, 4h minus 1 times 3 minus x minus 4x minus 1 times 3 minus x minus h. That will be all over my common denominator of 3 minus x minus h times 3 minus x. So as usual, we're never going to expand the denominator, but we do need to clean this numerator up and see what's going on here. So when I'm distributing across 3 terms, what I'm going to do is I'm going to take 4x and multiply it by 3 minus x, then 4h, right, and then negative 1. And then similarly, I'll take 4x, multiply it by everything, negative 1, and multiply everything. So if we do this piece by piece, we can make sure that we've got all the things that we need. So first, let's do 4x times 3 minus x. So 4x times 3 is 12x. 4x times negative x is negative 4x squared. 4h times 3 is 12h. 4h times negative x is negative 4xh. And then I have negative 1 times 3, so that's negative 3. And negative 1 times negative x is positive x. Over here, I have this minus sign I have to take into account. So really, I'm going to say minus 4x times all of these things. So negative 4x times negative 3 is negative 12x. Negative 4x times negative x is positive 4x squared. Negative 4x times negative h is positive 4xh. And then this negative times this negative 1 really makes that a positive 1. So positive 1 times all of this is just going to come back as itself. So plus 3 minus x minus h. All of this is under our common denominator, which we're not going to expand. So now let's see if we can combine any like terms. So just like before, everything without an h in it should hopefully disappear. And if it's not, that means we've made an algebra mistake when we multiplied things out. So I have a positive 12x and a negative 12x. So those add up to 0. I'm not canceling, they add to 0, right? I have a negative 4x squared and a positive 4x squared. They add to 0. I have a negative 4xh and a positive 4xh. I have a positive 12h, right? I don't have anything to cancel that with. I have a negative 3 and a positive 3, and I have a positive x and a negative x. So if I simplify what's left, I have a 12h minus h, so that's going to be 11h. And then it looks like it. And then I have a 1 over h. And I want to double check this to make sure we did this correctly. So let's double check this math. So 4x times 3 is 12x. 4x times negative x was negative 4x squared. 4h times 3 was 12h. 4h times negative x was 4xh, or negative 4xh. Then we had negative 1 times 3, negative 1 times negative x. We have 4x times negative 4x times 3, so negative 12x. Negative 4x times negative x, so positive 4x squared. Negative 4x times negative h, so positive 4x. Positive 1 times 3, positive 1 times negative x, positive 1 times negative h. So we end up getting, once everything else canceled, all I have is 11h over all of this stuff in our denominator still. So I'm going to write my 11h like that so we can see it. So the h's cancel. And so now my difference quotient simplified to this. So now I can take the limit as h goes to 0 of this expression. And so now we can see, well, if we plug a 0 in for this h, it's not going to make the whole denominator 0. So that's going to be perfectly fine. And what I'm going to end up with is 11 over 3 minus x squared. Because once I plug in a 0 here, I've got 3 minus x times 3 minus x. All right? So this is our expression, okay? And then in B it says, well, determine all the values at which the function fails to be differentiable. So this one, I want you to kind of put a star by, because what we have to do here to test for this is we can't just look at the derivative itself. We're definitely going to look at the derivative, but we also have to check the original function, because remember, you can't take the derivative outside of the domain of the original function. So if we look at this guy, well, the only value of x that is not allowed to be plugged into this function is 3. 3 would give us 0 in the denominator. So the domain of this function is negative infinity to 3, not included, and 3 to positive infinity. So we would say that, right, f of x is undefined at x equals 3. That means f prime of x is undefined at x equals 3. However, if we look at the derivative function we came up with, right, we also see here that 3 would give you 0 in the denominator. But it could turn out to be a situation where you have a value that gave you 0 in the original expression, but a second value might pop up when we take the derivative that would then give you 0 in the denominator of the derivative. So we really need to make sure we're checking both functions, right? Anything that wasn't in the domain gets kicked out, and anything that doesn't work in the derivative function you would also kick out. So we would say that it is undefined at -3 and at f prime of x, and it's for two reasons. The first, we can't differentiate outside the domain of f of x. So none of those values would ever be allowed. And two, if we look at f prime of x, it only exists from here to here. So the derivative function would not accept 3, but the original function would also not accept 3.